Good evening, students. Welcome back to Physics Fun Room. Today, we will discuss the chapter in the class 11 Gravitation. We all know about the falling of the apples objects towards the earth or the rotational motion of earth around the sun. This is all about the concept of the gravitation. It gives all about the concept of the gravitation. So, who is the inventor of the laws of gravitation? Inventor is Isaac Newton. So, first we'll learn the Newton's gravitational law. Newton's law of gravitation. What is Newton's law of gravitation? Newton states about this law that all the objects in the universe, all the objects in the universe attract each other with a force. That force is directly proportional to the product of their masses and inversely proportional to the square of the distance between the objects. So, let's draw a diagram to better understand the concept. This is two objects of masses m1 and m2. m1 and m2. They are separated by distance r. In between them, there is a attractive force. This is F. F is the attractive force. M1, M2 are the masses of the objects, and r is the distance between the objects. Now, force is directly proportional to the product of their masses, that is m1 into m2, and inversely proportional to the square of the distance between them, that is F is proportional to 1 by r square. Now, combining them, we have F is proportional to m1 m2 by r square. Now, if we want to remove the proportional sign, we should introduce a constant. That constant is the g, that is capital F is equals to caps G m1 m2 by r square. This G, the name of this capital G is the universal gravitational constant. Now here we want to find the unit of the universal constant and the dimension of the universal constant. How to find? Here we have A equals to G into M1 M2 by R square. Okay. Now G is equals to F into R square upon M1 M2. Okay. Now to find the unit of capital G. Unit of the force in the SI system is Newton, Distance r is in meter and masses m1 comma m2 are in kg. Now putting this force Newton r meter and m1 m2 is kg, we have g unit is, F is the Newton, distance is the meter square, as here r to the power 2, by masses product, that is kg square. Now Newton meter square kg to the power minus 2, which is the SI unit of the gravitational constant. Now to find the dimension, dimension G dimension, we have here the capital F is the force, and what is the dimension of the force is ml t to the power minus 2. We already know about the dimension of the force. Now the distance dimension r is L, and m1 comma m2 dimension is cap same. Now putting this in that, we have m L t to the power minus 2 into r square means L square, and here upon m into m, that is m square. Now we have L to the power 1 and here is the L to the power 2. So addition of that, m L cube t to the power minus 2 and m square will be in the numerator position. We have m to the power minus 2, m to the power minus 2. Now here m to the power 1 minus 2 is the minus 1. So m to the power minus 1 L cube t to the power minus 2 is the dimension of the gravitational constant G. Now here we have asked in the examination that why G is called universal constant. Why G is called universal constant? Let's focus on that point, that why G is called the universal constant. On the earth, on the moon, on the sun, or any other terrestrial objects, the constant has a fixed value 6.67 into 10 to the power minus 11 SI unit. So the value of this G remains constant irrespective of its position. It may be on earth, maybe on sun, or maybe on the moon. And also it does not depend on the state of the matter, whether it is liquid, gas, or the solid. So it is called the universal constant. Now let's move to the another concept. That is the acceleration due to gravity. We have already know about the acceleration due to gravity. What is acceleration due to gravity? If we take a chalk and ready to take its position in a height and release it, it will move towards the center of the earth, that is on the surface of the earth, if there is no hindrance in the outside. So the acceleration it generates in itself is called the acceleration due to gravity. This is a chalk. If you fall it from a height, it has an acceleration. It's called the acceleration due to gravity. An acceleration due to gravity, is denoted by small g. It is denoted by small g. Now here we have to find the expression of the small g and the unit and the dimension of the g, as g is the acceleration. What is the original name? Is the acceleration, and the acceleration generated by the gravity. And we know that the unit of the acceleration is meter second to the power minus 2. And so the unit of the acceleration due to gravity is the same, and the dimension of the acceleration due to gravity is the dimension of acceleration, that is L t to the power minus 2. Now what is the value we have to take in the examination? It may be given on your question paper, or you may take the two possible values. They are 10 meter second to the power minus 2, or it may be 9.8 meter per second square on earth, right? On earth. Now to find the expression of the acceleration due to gravity, we know from the Newton's law of gravitation, F is equals to G, capital M is the mass of the earth, capital M, we here take the capital M is the mass of the earth, and the mass of the object is small m, and the radius of the earth is capital R, R square. Now here the acceleration due to gravity, that is A, G, F by M. Now putting F in that expression, we have gmm by R square by small m. So here we have gm by R square. That is the acceleration due to gravity expression is the gm by R square. Now let's move to the another concept. Sir, it changes with the height or the depth? Yes, student, it changes with the altitude and the depth, making the earth's surface a reference. If we take an object away from the earth's surface, the acceleration due to gravity will change due to altitude, and due to depth it also changes. So here we have to do some work how it changes with the altitude and the depth. Now let's move. In the first case, change of g, that is acceleration due to gravity, due to altitude. Now let's take the earth's surface. That is the earth's surface. It has the radius of r, and the mass of the earth is cap m. Now at the point O is the center of the earth. At the point A, the expression of acceleration due to gravity g is equals to gm by r square. We have calculated. Now taking it away from the earth's surface to an altitude of the h. Now what is the total altitude from the center of the earth? We said that is r plus h. Now takes the point is B, and here the acceleration due to gravity g dash is equals to gm by r plus h whole square. Now we have to find the ratio of g dash and g. We have g dash by g is equals to gm by r plus h whole square by gm by r square. Now gm will cancel out. We have the expression r square by r plus h whole square. So g dash is equals to r square by r plus h whole square into g. which is the expression of the change of the acceleration due to gravity due to the altitude. Now, if we consider that the height is very minimal, that is 700 kilometer, 800 kilometer, what will be its expression becomes of the spatial expression it contains? Now let's move to that case. We write that is h is much less than caps r. Thus the height is very smaller in comparison to the radius of the earth. Now we have g dash by g is equals to 1 by r plus h whole square by r square. Yeah, that is equals to 1 by equals to 1 by let's take my duster. Okay. Now r plus h by r whole square, that is equals to 1 by 1 plus h by r whole square. Now here for the next line, g dash by g is equals to 1 plus h by r whole to the power minus 2. Now what we have considered, we consider that h is much less than caps r. So the expanded expression we have 1 minus 2h by r. So g dash is equals to 1 minus 2h by r into g, which is the expression applicable for the numericals, in which case the h is much less than caps r. So we have learned the enough topics for the day. Please stay tuned, subscribe my channel to have the latest chapters, latest concepts about the gravitation in the next class. Please share, subscribe my channel to enhance my potentiality.